Morning, students. Today is December the 3rd, 2022. So I hope you had
January, doctor, not
morning.
December.
I hope you all had a good holidays, vacations, relaxed, and you're ready for this last 4 weeks of the semester. Okay. First, I would like you to know what is our plan for this coming 4 weeks. So I'm going to share the screen and I'm going to write in a small, well, on the screen. Then I would like to spend some minutes working with you the solution of the last problem of the quiz 2. We didn't complete it last session. And in the last part of this today's session, we're going to make a control of your progress in the project, okay? So we want to see how far have you come. We want to see if you have any problems, difficulties, issues. So we try to solve. And at the end, we're gonna have another session and we can answer some general questions about this project. Okay, so those are the 3 things that we're going to be doing this morning. So I'm going to start sharing here. Okay, so let's see here. So we have let's say let's do this. Oh, Jesus, what happened? What happened? What happened? Okay, so say next. Can you see what I'm writing?
Yes, doctor.
Yes, doctor.
Okay. So this is what we mean, okay? What are we going to do in this next 4 weeks, okay? So let's see, I have my little note here. So let me write some horizontal lines to divide in weeks. So that's our first week. This is this week. Then we have, this is the 5th. This is 4th, 5th. No, this is the 5th week. This is the 6th week, and this is the 7th week, okay? And then we have exams, okay? So we have, this is, vertical is difficult. So we have, this is Monday, Tuesday, Wednesday, Thursday, and Friday. Okay, so today is the 3rd, okay? And today we're going to do progress control, okay? And we're going to do solution of quiz 2, second part. Okay, so this is Monday, and this is Thursday. Okay, here we're going to start chapter 5, okay? And we are going to do frames. Okay, so I'm going to give you some material to review before the class, okay? General material. And then during the class, Engineer Isaac will explain, okay, some details of that material. And at the end, we're going to do an exercise, okay? So this is what we call flipped class. So hopefully everything will be fine. So I'm going to send you some material the day before on Wednesday. You have to review it, practice a little bit, and then during the class, Engineer Isaac will explain in detail some advanced topics, and then at the end, we're going to have an exercise in class, okay? Then on the next Monday, this is Monday the 10th, okay, of January. We're going to do the second part of chapter 5. So we're going to do chapter 5. And then here we have plate structures. Okay, similar to this, but in this case, we're going to have plating, which is more common in our type of structures. Okay, ship type of structure usually use a lot of plates. Here, this is a very simple exercise with only frames. Okay, it's modeling the bridge with frames. Okay, and here, of course, we do progress control. Okay. Okay, here, this is 13th, January 13th. We're going to do progress control again. Okay, and then on the 17th, I'm going to give you the third quiz. Okay, so here, this is Rhino plus ANSYS material. Okay, so this quiz is very important. Okay, because I think I said a couple of weeks ago that last year, and that there's something our responsibility to be sure that when you approve this class, you have minimum skills using ANSYS. So this is very important for me. And then here on the 19th, this is Wednesday. Okay, we're going to have the naval engineering students technical sessions. Okay, so probably 2 groups from this class will be randomly selected to participate in the naval engineering students technical sessions. Okay, so this is random. Or if you offer yourself as a volunteer, you can participate in these sessions. Okay. And then in the exam week, I posted last night the material or the problem of the project formulation. Okay, and according to that, on Tuesday, this is Tuesday 25th. People, this is the official date. You have to present the reports by noon. Okay, so I have in the afternoon, I will review those reports and be ready for the 26th, which is the official day for the final evaluation, right? So on these days, we're going to have the presentations. So probably we're going to go from 7 to 10 because that's, you have, okay? So more or less, that's the agenda for these 4 weeks. People, is there any questions about this? Any questions, any detail? Please notice that this is a change, okay? Originally, I posted to work on Wednesday and Thursday, no, but I was wrong. This is the official day for the final exam. That's Wednesday 26th. That's why I have to put it here. And the day before, I want you to turn in the report. I have to tell you that I'm going to be very strict on the project, okay? Believe me. So I'm not going to give points away. Any questions about this? Any questions? Questions about this our plan for the next 4 weeks? No question, everything is clear? Okay, good. So let's go to the second point of our agenda. Today, we're going to complete the exercise. You have to do it, not me. Okay. So I'm going to check if I can. Two, 3, and 4. Some people complain about the program, the evaluation was very long, and I have to tell you that it wasn't. And the problem is that you waste too much time in writing things that you don't have to. That's the problem, because you just sit and write. That's the problem. Okay. So I have to share screen. Okay, can you see problem 2, people? Can you see problem 2?
Yes, doctor.
Okay, thank you. So the problem was about solving this structure. I went through a couple of comments here, okay? And one of the comments is that if you try to solve this, okay, of course, most of you were able to identify that you have to analyze only this triangle. But I have to go to the other. Here. So I'm going to, that's done. Okay, so can you see my white screen, people? Can you follow my explanation? White screen?
Yes.
Okay, so about this is quiz 2, and this is problem 2. One of the things I'm going to try to do this year is try to improve my handwriting, okay? So believe me, I'm doing a good effort. Okay, so the original problem was this, okay? You have a clamped left edge, and then we have something like this, okay? And then we have a force pointing to the right, okay? Now, if we want to analyze, Isaac, there is some students in the waiting room. Okay, if we want to analyze this system, okay, originally, so we use 3 joints, okay? Remember, this is something that we explained, we mentioned in class, is that if we have n, a system of n equations, if we want to solve it, we have to have n unknowns also. Okay, so here, in this case, we have 6 equations. Okay, so in this case, we have 6 unknowns. Okay, so let's call this is 1, 2, and 3. So let's list here what are the unknowns. Mr. Valles, what are the unknowns in this case, in this problem? What are the unknowns?
Joint number 3 and number 2.
No, those are known. You know how much
No rotation and no.
But that's, see, please, Mr. Valles, read what I'm writing here. What is something unknown? That's something that you do not know. What are the unknowns in this problem?
In direction, the displacement in direction y and x in number.
Okay, that's
Exactly.
2.
Exactly.
But you have 6 unknowns. What are the other unknowns?
Number 2 and number 3 in direction number u.
What in direction?
X and y.
No, what parameter? What parameter you do not know in joint 2? Mr. Ortega, Albert Ortega, what are the parameters that you do not know in joint 2?
The parameters.
Yeah.
The force.
Exactly.
The velocity.
So
Yeah.
you know Fx2, Fy2, and similarly in joint 3. So you do not know Fx3 and Fy3. You count and you see that you have 6 unknowns. And on the right here, I'm going to write in with different color. Let's use green. Here, I'm going to write the corresponding parameters in each one of these equations. See, you do not know the displacement of the joint 1 in the x direction, right? But you do know the force in the x direction. You do not know this, so you know the force in the vertical direction. What's the force in the vertical direction, Mr. Ordóñez?
That's 0.
This is a value that you know. So you know this, in this case it's 10 tons, you know this, 0 tons. In this case, you do not know this, and you know U2, you know V2. You know U3, you know V3. This you know, this you do not know. Now, let's analyze using symmetry. Okay, now using symmetry, you have half of that, this and that. Let's use join 1, join 2, and join 3. Again, you have 3 degrees of freedom. I'm sorry, you have 3 joints, and you have 2 degrees of freedom for every joint, right? So you have to have 6 equations. And of course, you are going to have 6 unknowns. Now, what are the 6 unknowns in this case? In joint 1, Mr. Galarza, what are the unknowns in joint 1?
For this case, should be the displacement
In what direction?
in X.
And what happened with the displacement in the vertical direction?
As we don't have any force in the vertical direction, we could
No,
say that
no,
it's
that's
zero.
not the reason. That's not the reason. That's not the reason. If I take this and I put just something like this, okay, I don't have force in the vertical direction. If I apply a force in the horizontal direction, I'm going to have a displacement in the vertical direction in this case, even though I don't have a force in the vertical direction. So that's not the reason.
Mm-hmm.
What's the reason why I don't have displacement in the vertical direction? What's the reason? Mr. Nevares.
Can you repeat, sorry?
What is the reason why I don't have displacement in the vertical direction in joint 1?
Because of symmetry, I fix it.
Exactly. So this is something that I know. Know this. So if I do not know this, in that case, I do not know the force. Okay, in this case, I know force. There. So you have to be clear with this. Because if you assume that this the displacement is 0 here, or in this case, the displacement is 0, and you have no force, then you have only 5 unknowns, and that is incorrect. You cannot solve a 6 equation systems with only 5 unknowns. And this is something that we mention in class, we explain in class. Okay? And the other, of course, are the same: U2, V2, U3, and V3. And here, the unknowns are the reaction, there. You see, it's not the same. At the end, we're going to have that these forces here are going to be equal to these forces here. Okay? Questions, people, questions? Questions? Okay, so that's one thing that I wanted to say. Another thing that is very interesting is that in this example, okay, you have to do a matrix. I'm still in problem 2, okay? You have to do a matrix operation. You have K is equal to a constant I'm not going to write, and then we have the B transpose, the D, that's the relationship between stresses and strains, and then you have B here. Okay? And we agree a few minutes ago that we have only one unknown, right? And the only unknown that we had was U1 as far as displacements is concerned. So in the first step that we have to do to solve this system of equation, we have to find the unknown displacements. In this case, we have only one unknown displacement, that's U1. Now, the thing is this, okay? I have something like this. What happens if I put this as joint 1, this as joint 2, and this as joint 3? In this case, I'm trying to find U2. And in here, that's going to be the third equation. So in this case, you have to find the element K33, because this is a 6 by 6. So it's kind of difficult to identify in this product the element, the element in K, which is the K33. Yeah, of course, that's one thing. What happens if instead of that, I do this? I name this joint 1, this joint 2, and this joint 3. Immediately, you see that this is the correct order of numbering the joints. But now, since the joint 1 is the one who has the displacement unknown, in this case, the element that I'm interested is element K11. That means that I have to take this row, make this product. Okay, this is a 3 by 3. This is a 3 by 6. And the result is going to be 3 by 6. Okay, so I have to multiply this times this. And the product of these 3 elements times these 3 elements will give you K11. So if I identify this as the first joint of this element, it will be much easier to identify the column and the row that I have to multiply in order to get K11. Don't you think so? And everybody did the other way. Name this join a join 1. So in this case, you have to identify, I'm going to write like in red. So this is the third row, and this is the third column. But I think it's more complicated to do this instead of doing in blue. Okay, so if I name this join 1, 2, and 3, I have to work with red. If I name this as join 1, I think it's much easier to identify the elements that I have to multiply in order to get K. And that is the only element in K11 that you need to identify. And as I told you, okay, I told you that this element here is 0. And this element here is 0. The second element is 0 also. So this is, I think it was beta 1. Yes, this is beta 1. And this is gamma 1. So this is beta 1, 0, and gamma 1. So if gamma is 0, the only element that you need to calculate was beta 1. And please don't tell me that that's too much. People, any comments? Any comments, people?
I have a question, Doctor. Good morning.
Yeah.
Can you hear me?
Yeah, now I can.
That if we need we need one element, we avoid calculate all the
Yeah.
metrics, right?
Yeah,
Yes.
yeah. See, the thing is this, okay, you have a 6 by 6, and then you have U1, V1, etc. And then on the right-hand side, we have F divided by 2. We have F Y1, F X2, etc. So this is the system of equations. What is the first step that we do? We identify or we solve for the unknown displacement. So we solve for this unknown displacements. And what are the unknown displacements in this case? U1. So you can put here all these big K's that you want, but if you have one single displacement, what's this equation that you have to solve? You have to solve K11. I'm sorry, let me erase this. So K11 U1 equal F divided by 2. And to solve this equation, I only need this. And then U1 is equal to F over 2 divided by K11. Jimenez? I didn't ask you for the reactions.
Yes.
I just asked you for the displacement. That's all, right?
Right.
Okay. So that's all what you need to calculate. The problem is that you don't read, you don't try to understand. You just write. And you could see your solutions. And so people write the whole matrix here. What for? And the thing is that you're just trying to fill up pages. That's all. And that's not what we want from you. Okay, if there are no more questions, I'm going to go to problem 3. Is there any other question, people? No questions? Okay. Now, people, I want everybody to take a piece of paper because I want you to calculate with me, okay? I'm not going to solve the exam. That's something I don't like. I want you to solve it. I'm just going to guide you with this. So please turn on your cameras, get a piece of paper, get a calculator, because I want you to participate, okay? So I don't want to waste time asking somebody, and yeah, please be alert. So I'm just going to call those who are, I can see their faces. Okay, please. So please turn on your cameras, because the others, I'm just going to assume that they're not here, because I don't want to waste time. Okay, so first I'm going to show you the problem. Here it is the problem. Okay, so this is the part of the file with the results. This is something that you did widely because you prepared a report. Okay, so here you have the information about the material. These are the information about the joints. So here you have the positions, and you can read here X and Y. You have either the displacement in X or the force in X. Here you have the displacement or load in the Y direction. And as you can read here, I changed the value, and instead I replaced it and put it an Fx. Okay, here you have the connectivity table. You have 6 elements, and you have the joints. Joint 1, 2, 3, and the 4 was equal to the 3rd because we are using triangles for the discretization. And finally, here are the displacements. Question for you, Ms. Gutenberg. What are the units that you suspect for this structure, for this table of results? What are the units? Ms. Gutenberg? No, it's not here. Mr. Galarza? Mr. Galarza?
They should be millimeters.
Why you say that? What's the material of this? What's the material of this little piece of triangular support? What's the material?
Let me see.
It's here.
Material 1.
Mr. Barba? Mr. Barba, can you tell me what's the material of this structure?
Doctor.
Yeah.
But the modulus is in newtons over meters.
Yeah,
Square.
exactly. So what
the
are the units
displacement
of the displacement? What are the
is
units?
in meters.
Exactly.
Is in meters.
Exactly. So, and you see here, it says that it is in steel. Can you read? Here I say steel. And I'm giving you this value. And this is something that we insisted in this, well, not only in this class, but in every class that I teach in the area of structures, I insist that it's a good idea to have the basic values of the steel in your memory. So as Mr. Baez said, you see this value for the modulus of elasticity, and you say that this is steel. So immediately, these are the units that are guiding our problem, newtons and meters. So here, so this is the position. For example, at the end, this is 0.1 and 0. That's 10 centimeters triangle. And you see that this is 20 by 10. We have done nothing except checking the information that I have. Okay, so this is U and V. Units are meters. So the first thing that you have to do is take this information and make a plot. And that was the first problem when I started grading, because I saw that some of you were not able to put this information in a sketch of the system. And I'm going to, I said, I'm going to penalize you because I think it's unacceptable that you are not able even to take this information and transform that into a sketch of the system, of the discretization.
Doctor.
Yep.
But I practice this exercise. But I intend to grab the discretization, but I could not do the values that were raised to exponent -1 in the XY. Yes, in this I fail, but in the report, I realize more the 6 discretizations. I prove with more than 100 elements. It seems unfair that they penalize just twice, since the time we spent.
Yeah, but you can
work.
See, everybody can assure me that I did the work, I did the work, I did the work. I prepared the files, I did this, I did that. The problem is that I'm right here, and I know that some of you are not telling me the truth. Are you going to tell me that everybody in this class worked the same to prepare the project? Are you going to tell me that? You can tell me that. I'm not going to believe it. There are many groups in this class which just include the name of some of your classmates or your teammates just because you're friendship. But you recognize that those students are not working enough.
Doctor, but I intend to grab.
How can I identify those who work from those who didn't work? The only way is just to give you something like this. Six elements, 7 joints.
Exactly, is very
Extremely easy.
easy.
It's not easy.
Exactly.
Say it with me. It's extremely easy.
Yes, doctor.
I'm sorry, I'm not going to discuss it. If you don't agree with me, you can take you can send to the Consejo de la Facultad to ask for a regrade of this. And the problem is that, are you going to tell them that you were not able to take these values, X, Y values, and put it in a sketch? Are you going to tell them that you were not able to put this into a sketch, XY sketch? Not a 3D, it's a 2D problem. If you want to do it, do it. I'll bring my lawyer, bring yours. But I'm sorry. This is extremely easy. I'm not going to discuss. This is just, for me, just a proof that you did not think. They just, I don't know.
Doctor, I can grab the discretization, but I don't see the rise to the exponent -1.
But the problem is this, Mr. Valles. Did you prepare the report?
Yes, I
If you are not able to take this information and put it in a sketch, that's telling me that you did not work in the report. That's for me. Maybe I'm wrong, but I have the evidence. The evidence that if you're not able to take these 6 elements.
Yes, I recognize.
It's not 100 elements. It's just 6. I'm sorry.
But in the report, I
Yeah,
realized.
I'm not going to discuss. Okay, if you are not, you do not agree with this, you can send a complaint to the council of the faculty, and they have to decide. That's my resolution. Okay, let me go on. Okay, so that's one thing. Now, let's go on. So let me go to, please, everybody, get a paper. Okay, so, a second, here it is. So I'm going to work with problem 3. Okay, here is the discretization. Okay, I'm going to write a large. No, because it's 20 by 10, okay? So if this is 20, this is 10. So from here to there, it's about here. There, here. I think it's something like this, right? There. So this is fx, and we do not know how much that is. Okay, so I want you to calculate or to integrate the force around here. Okay, so everybody, please make a sketch. This is y, see? Y is measured in this direction. This is x. And here, I want you to plot sigma x. Okay, so please make a sketch of this distribution. Everybody, make a sketch of this distribution. Miss Matias, can you hear me? Miss Matias, can you hear me? Mr. Zambrano, can you hear me? Mr. Zambrano, can you hear me? Mr. Zambrano? No? Mr. Matute, can you hear me? Matute?
Yes, doctor. Good morning.
Good morning. Can you describe the distribution that you have here? Okay, this graph will start at a certain point and end at a certain point. What's the maximum point that you have here, Mr. Matute? What's the maximum value that you have here? So here we are going to have a distribution. What's the maximum value here, Mr. Matute? What's the maximum value? No? Miss Vega, this is I'm going to write in centimeters. This is 10. So from here to here is 10. From here to here is minus 10. And here is plus 10. So in this direction, we have 20. Okay. So I'm asking you, Mr. Matute, what's the maximum value of a y and the minimum value of y? Anybody can tell me what's the maximum value?
Minus 10.
Minus 10 and 10.
No. See, I'm writing here. So 10 is here. So this has to be less than 10. Because I'm going to
-5.
-5. No, it's not.
No, 7.5.
Exactly, 7.5. So this is plus 7.5 and minus 7.5. And what happens from here to there? What's the variation of the stress from here to here?
There's no variation.
Exactly, it's constant. What's this point here? This point here, how much is this point here in Y? Because I'm trying to identify this into here. What's this value? What's the ordinate value of this point?
2.5.
2.5, yes. So you have 7.5 and this is 2.5, so this is 1/3. Now, everybody, prepare a plot and a sketch of the variation of the stress in this area. Please, everybody. Can you show your plot on the screen? Anybody can do it? Mr. Jimenez, can you do it? Can you show, can you put your plot on the camera so I can see what you have? Your plot. But put your plot on the camera so I can see it.
You see, I
Uh,
guess.
no,
Yeah,
no.
no.
See, we just said, Mr. Ortega, what did you say about the stress in the first part? What did you say about the stress distribution, the variation? Mr. Ortega?
It's a constant.
It's a constant. But you're showing that it's a variation. So that's not correct. Mr. Ordóñez, do you have your graph? Can I show it on the camera? Yes, that's so. Now you're showing me that you're showing that in this part the stress is smaller than in this area. Is that correct? What happens if you pull from here? What is larger, the stress in this element or the stress in this element? This is element 1, and this is element 2. Which one is larger? Mr. Ruiz, which one is, which stress is larger? Sigma 1 or sigma 2? Which one is larger? Mr. Ruiz? Are you here?
Sigma 1.
Sigma 1 is larger? Do you agree with that, Mr. Ramon? Do you think sigma 1 is larger than sigma 2?
I think they is equal.
Are they equal? No. No. If you pull from here, see this region develops more stress than this region, which is away from the direction of the application of the load, of the force. So element 2 is in the line of the application of the force more than element 1. So I expect, I'm not sure, but you have to do the calculation. I expect sigma 2 being larger than sigma 1. So what I expect is that this is going to be something like this. In this area, the stress is going to be constant. And then from here to here, we're going to have a decrement. I don't know how much. And this is going to be equal to that. Okay. So this is the distribution. If I give you that this is sigma 1 and this is sigma 2, okay? then P is equal to the integration of sigma x dA. If you integrate in the z direction, you get the thickness. So it's going to be equal to the thickness times the integration from minus 7.5 to 7.5 of sigma x dy. And how do you calculate that? You see that from here to there is constant. You hear from here to there is constant. So that's simply equal to what? Sigma 1 times what? Anybody?
7.5 minus 2.5.
Exactly. Plus an x sigma 2 times
Minus 2.5 plus 7.5.
we're missing something here. What are we missing right now?
Sigma 1 and sigma 2.
No, sigma 1 is sigma 2. No, but in this formulation, to calculate P, what do we need?
The force.
The result is going to be the force, of course, but there is something wrong here because we integrate from minus 7.5 to 7.5. What's this integration? From where to where?
We have to multiply by 2. Because
Exactly. Thank you very much. Because it's symmetric. There you have it. So you need to calculate sigma 1 and sigma 2. Okay. And finally, okay, any questions about these people? Any question? Any question? No? Because I need to change. The problem is that if I go to the next page, then I have to erase this. Any questions about this the last time? Let me insist that this is sigma x. This is sigma x. So the only element of the stress tensor that we need is sigma x1, sigma x2. Do we need sigma y? Do we need tau xy? We need them. Ms. Vega, do you need this? Ms. Vega? No, you don't need them. For this calculation, you don't need them. I could call you. I could ask you to calculate sigma y, yes. And it's not going to be 0. Okay, because you're pulling here in this direction, and this try to contract because of the Poisson effect. And since this is clamped, that prevents from contracting. So that has to develop a sigma y stress. But I didn't ask you for that. So let's finally complete this. So we need only sigma x. Okay, now the thing is that we have to be aware that sigma x, sigma y, and tau xy. And this is something that I gave you in the problem formulation, so you didn't have to remember. So it's 1, no 0, no 1, 0, and 0, 0, 1 minus no over 2. And then you have here sigma, I'm sorry, epsilon x, epsilon y, and gamma xy. So tell me, Mr. Iñiguez, how do you calculate sigma x? Mr. Iñiguez, are you here?
Yes, okay.
Sigma x is equal to what?
It's equal to uh, uh,
Come on, you can multiply this. Mr. Arias, can you multiply this?
The young modulus divided by 1 minus the Poisson ratio before,
And then what?
multiplied by the epsilon x
Okay.
plus epsilon y multiplied by the relation Poisson.
So this is something very interesting. Okay. In this case, you could have said, and I don't take any points out of there. I'm going to write in red, because in this case, epsilon x is, you could say this, and this is incorrect, because this is for the case of unit strain case. In this case, no, because this is a plane stress. In this case, what happens in the x direction is coupled with what happens in the y direction. That's something that we insisted in this chapter. So this is the way to calculate it. So you have to calculate epsilon x, epsilon y. And finally, to complete this review, epsilon x, how do you calculate epsilon x? Mr. Carrillo, do you remind me, please? Epsilon x is equal to what?
Derivative,
Of what?
the mu, the u
U, exactly. Divided by,
over dx.
exactly. Now, u, in this case, we put it like this because this is an approximation. So we have to differentiate that. And here, remember that we have so we have ui, uj, and uk. Here I have ni, nj, and nk. And each one of these, it's 1 over 2a alpha plus beta I x plus gamma I y. Ms. Larrea, give me an expression to evaluate epsilon x in this case. Ms. Larrea? Ms. Larrea, are you there? Ms. Cumbe?
Yes, doctor.
Okay. Can you differentiate this? Can you differentiate this with respect to x? Equal to what? Can you take the derivative of this, Ms. Larrea? Oh, it's too difficult for you. Okay. Ms. Cumbe, can you differentiate this?
Good morning, doctor.
Come on. You see, that's my problem. That's my problem. You cannot even differentiate with respect to x. Come on, people.
1 over 2a.
1 over 2a, yes. Go on, please.
Beta I.
Beta I, okay. So this is beta j and beta k, and multiply by ui, uj, okay. Now, in this case, for this element here, okay, you see that this joint and that joint are clamped. So they don't move. So if this is joint 1, this is joint 2. So epsilon x for element 1, for this element here, is going to be equal to what? Anybody? Ms. Lopez, epsilon 1, just for this element here, is equal to what?
Be 1 over 2a.
Yeah, but you see, how much is U1, Miss?
Sería, sorry,
How much is U1? How much is U1? U1, how much is the value of U1? No, no. Please, listen to my question. Listen to my question. How much is U1? U1, how much is U1? No? Mr.
No.
Ramon, how much is U1?
It's 0.
0, because it's
Zero.
sample.
0.
How much is U4?
0 equal.
So this is 2 or 0. So the only thing that you are left is 1 over 2a. One of these is going to be 0. It's going to be beta 2 and U2. Is this complex? I hope you say no. Epsilon y, because you need epsilon y to calculate here. Epsilon y, the same element, is equal to what? Mr. Diaz, tell me, how much is epsilon y? The same element for element 1. Mr. Diaz, please. You see that some of you are just here because you turn on the cameras, but you're not here. You're not in class.
Yes, is 1 over 2a
Times,
gamma
okay, times,
u.
now you, it's epsilon y,
Yes, b.
B2. Thank you, good. Is this difficult to calculate? I hope not. I hope you say no. Any question, people? Questions about this? People, questions? No questions? Okay, in that case, we're going to take a break, and when we return, okay, I'm going to say 2 words, and then we're going to go to the rooms, group rooms, and then Miss Loyola, we're going to work with the groups 1, 2, 3, and 4. Engineer Isaac with the next 4, and I will work with the last 4, okay? And then we will have maybe 5-10 minutes at the end to get together again in this room, and then I will try to answer if there are any common questions about this project. Okay, so 5-minute break, 5-minute break.